Alrighty, so we all saw this, right? That was Canadian, eh? Okay, recall. What's the name of this thing? Some rule, some law, if you will, of logs. No peeking, Will. What's that called? Power rule. So, and because, well, what? A to the what power equals A? That's 1. That's just x. So I don't know if that's something worthwhile memorizing, because it's pretty quick to figure it out. And this I showed you yesterday, right? So if you learned it yesterday, you know it. And if you didn't, well, learn it now. Okay, that's pretty helpful. That one is pretty tough to figure out. I showed you how you can, but I don't expect you all to do that every time. I expect you to put that in your noodle, okay? So, what would this be then? Can you see that? It's kind of small, isn't it? What is that? Is that 10 log base 10 of 5? Yes. Yeah, because if it doesn't say, it's log 10 base 10. You see this? A log base A of x is just x. So 10 log base 10 of 5 is just... What a lively bunch. Well, hey, because I can... Oh, wow, look at that. It's 5. But you shouldn't need to do that, because you should have that in your noodle. What is 10 log base 10 of 7? Were you going to say 6? What is 10 log base 10 of anything? Anything. Okay, that's the rule. So using the new rule, simplify. I'm going to a skinnier pen. So what do I do here? Because it looks a little uglier, doesn't it? It'd be nice if it was just that. If it was just that, what would that be? 2 log base 2 of anything is just the anything. That would just be 5x, right? Now I got something added to it. So what can I do here? Two log base 2 of 5x let's when you have that, okay, there's no logs here. That's grade 10 stuff. What's the rule for exponents? Add them, right? So that's all I'm doing. I'm going from here and I'm backtracking. This is 2 to some exponent plus some exponent. So I want to go and split that up and go, that's x2 times x3. That's 2 to the power of that times 2 to the power of that. Okay? So that's not a log rule, that's an exponent rule. That's what this says. Okay? And I want to do that because this is just 5x, that is just 3x, and then what's in between them? Multiply. So that's 15x squared. Okay? Make sense? What happens if they're subtracted? x4 divided by x to the 1. What do I do there? That's exponents. I taught it in grade 10. It was called the quotient rule. And if you're dividing with the same base, what do you do with your exponents? Subtract. Are these exponents that are subtracted? So then to go backwards, if I have exponents that are subtracted, I can write that as the first exponent divided by the second exponent. So I'm going to write that like this. Divided by that. Same base. Okay? That's what I'm doing. And then what's this thing on the top? A to the power of log base A of anything is just the anything. And on the bottom, A log base power A, that's over 3. Can I simplify this? You bet. Okay? By the way, 3.9 will be a big chunk of the test. So we're going to get lots of this kind of stuff, solving, evaluating, right? I'm not saying this rule in particular, but all this is solving, evaluating, i.e. not a lot of graphs in 3.9, like none, right? Okay, what can I do with that? Using this new rule. So think to yourself, what can I do? Can I make it look like that somehow? What do I want that base to be? I want this base to be the same as that base. Yeah. 16 is what? It's 2 to the power of 4. I want a 2 here. Okay, so that's 2 to the power of 4. I still have the power of log base 2 of 3x. So I just multiply those together. That's the same thing. Okay? Because that is 16. Now what? Well, I got this little 4 in the way here. Okay, that doesn't look like that yet. How do I make it look like that? What can I do with this 4? I can huck it out there because I recall power rule. So that is the same as this. Now it looks like this guy. Okay, that's 2 to the power of log base 2 of that thing is just that thing. And that's all I can do to it. Are we having fun yet? Good, thank you. Okay, same kind of question. Looks really similar. What do I want to do with that quarter? I kind of want to make that look like a 2. So a quarter is, how do I make it look like 2? What do I got to do? What power do I want to put here to make it a quarter? Yeah, that's a quarter. That's 1 over 2 squared, which is 1 over 4, which is a quarter. So that's what I want to substitute in here. Negative 2 log base 2 of 3x. Do these brackets matter? What if I had brackets here? Then I would have to have them here, wouldn't it? Absolutely they matter. Because this 4 is not on that 3. If it was, it would be 81, right? So this, make sure you have them. And then, I don't want this here. I'm going to put it over there as an exponent. Okay, that's -2. That's fine. And then that is just this thing. Is that how I want to leave it? Probably not, because remember in grade 10 we always said write your answer with a non-negative exponent. If that was on a government exam multiple choice, that wouldn't be one of the answers. That wouldn't even be one of the answers, but that would be. Okay, that 2 applies to everything in the brackets, 3 and the x. Okay, so if you like the English, if you find that helpful, feel free to read that. It's kind of what I've been doing. Those were just simplifying, right? Because there were no equal signs. Now there's an equal sign. It's an equation, so we call it solve. What is x here? Well, what can I do? Can I make that look like this? That's log base 2. Could I just do that? Whatever I do to one side, do to the other side? Why the heck not? Right? Make everything power of 2. As long as you do it to both sides of the equation, you can do it. And I want to do that because 2 to the power of log base 2 is just this thing. That looks a little nicer. What is 2 to the power of 0? Anything to the 0 is 1. That looks a little nicer. Now that you saw that, guess what my next step would be? Well, yeah, that's what I want to do, but why not? Because what's 3 to the power of log base 3? Just the thing itself. What's 3 to the 1 power? Aren't these fun? Can I check that? Put that back in here. What is log base 3 of 3? That's 1. And I got log base 2 of 1 now equals 0. Is 2 to the 0 equal 1? Bingo, it works. If you can check it, why wouldn't you? You got time? You done your test? All right, same type of question. What am I going to do? Yeah, I want that to say this. Whatever you do to one side, do to the other side. Careful, make sure you put brackets there. The whole side to the power of 9. What's the left side, Dan? Yeah. Yeah. And what's this? That's kind of hard to see. Let's rewrite it. What's 9 to the power of -1/2? Let's do something with that. That is, I don't want to do that. I want to do that, right? I want to make it positive. What does a half power mean? Should have it memorized. What's a half power? Square root. You know what the square root of 9 is? Yeah, that's a third. But hey, don't take my word for it. Trust thy calculator. If you can know how to turn it on. There you go. 9 to the power of -1/2 1/2. Does that look like a third? I don't know. I hate fractions. Math, fraction. Hey, it's a third. Okay. What's the next step? Do you know 2 to the 1/3 power? I don't. But I do know I can take both sides to the power of 2, and x is, oh look at that, I got the same thing. 2 to the 1/3 power? That's the answer. You want to make it a radical? Maybe it's multiple choice. Maybe the answer is a radical. What's that as a radical? We better do it. The bottom part is the radical part. The top part is the exponent part. Okay? Maybe the answer will look like that. You got to know that's the same thing. Can you check that in your calculator? Is it going to make the same decimal? You bet. Okay? Moving right along. What do I do with this guy? How can I make it prettier?
Make that all the power of 2.
Yeah, but can I do this? Can I just go and do that?
No.
Yeah, because I want to do something else first. Okay? There's a plus in here. I want to join those first. Is there a rule up there on the wall? Is it called multiplication rule? Yeah, same base. This is x. That is y. If they're added, I can join them and multiply them. Same base. That's x minus 3 times x plus 1. Hey, what does that look like? Looks like a polynomial. Now I want to take power of 2 to both sides, if that's worded properly. I got that. And 2 to the 5 is 32. What was the question? It said solve, right? How do I get x here? Let's go back to math 11. Actually, this is math 10. Okay, expand this guy, FOIL it, x squared and x minus 3x minus 3 is 32. Do you see what x has to be here for this to work? Because I sure don't. So let's bring 32 over there. Let's collect these x's. Minus 35 equals, it's still an equation. What do I got on the right-hand side if I get rid of that? Yes, important part. This is an equation. Math 10, you wouldn't have that. It would just say factor, right? Math 11, you get that. Now we got to solve it. What are the values of x that will make this thing work? Well, what multiplies to negative 35 and adds to negative 2? Everyone agree? Okay, they're not going to be hard ones to factor, guys. Okay, they're not. I'm not even going to give you a number over here, except 1. So you can do every one of them by inspection. So don't freak out. I know you all hate factoring. So, when does this work? When does this equal 0? What value of x? When does this equal 0? Okay, now, something we don't know. You got to check. Remember that stuff? Yeah, because if I put 7 in here, I got 7 minus 3 log 2 of 4. It's probably all right. If I put 7 in here, log 2 of 8, hey, I know what that is. Does it work? Log of, what was that again? 4? What's this? What's that? Does it work? -5. If I put that in there, let's ignore the log 2, base 2 for a sec. What is a log of, if that's -5, -8? Can't do it. You can't take the log of any negative. Okay? So, remember this. You have to reject any negative, not the number, but if the log is negative. Okay? Can't do a negative logarithm. Well, I want to lose easy half a mark. I don't know, depends on my mood. Okay? You can't take a log of a negative. And I'm not going to say why or prove it or anything else, just trust me. Okay? So there's going to be an answer that'll work, there's going to be one that isn't, that one doesn't. Okay, what do I want to do with this guy? Same type of question. That's just log base 10. But wouldn't it be nice if I could just get rid of it? But before I do that, there's a negative in there. Is that a rule up on the wall? Division rule. Divide that over that. Oh, but I got a 2 there, so that's an x squared. Okay, well, let's just do one bracket. Equals 0. Okay, division rule. They're subtracted, they have the same base, log base 10. I'm going to do that. Now, I will take both sides, the 10 power, because that's log base 10, and then I just have this thing. What's 10 to the 0 power? Still 1. So, how do I solve this for x? Well, cross multiply, right? Just half of it anyway. I probably want x squared to be positive, so let's chuck everything over to that side. And what did I forget? This is still an equation. When does this thing equal 0? Do you see what values of x where this will work? If you do, don't bother factoring it. I don't. Just factor it, right? So what multiplies to -6 and adds to 1? Those two guys. Make sure you check it, right? X squared and 3x minus 2x. That's plus 1x. -2 times 3 is -6. This is equal to 0 when x is 2 or -3. Then I want to check it. If I put 2 in here, that'll be positive. That should be fine. That's positive. That should be fine. -3. Can I take the log of -3? Should I prove it again? Oh, reject. Okay, that's it. That's all you got to do. If this log is a negative, can't do it. So you just cross out that one. That's the answer. X is just 2. I should actually check that, but you know what? Don't worry about it. All right? Okay, what do I want to do with this? It's the same as before. I just want to do one step first. I want to collect these log x's together. One's on one side, one's on the other side. So I'm going to take this guy and put him over there. Okay? Now it's very almost exactly the same as this question. It's plus, join them together. That's multiply. Okay, 10 to the power of both sides. Make a nice factorable polynomial. X and 4, x minus 3. So x is either negative 4 or 3. One of them works, one of them doesn't. Okay, don't just, you might say to yourself, just cross off the negative one. Don't be so fast, right? If this is a negative x, remember if I put a negative in there, it's positive. If it's a negative x and I put a positive in there, it's a negative. So just make sure you take a little peeky, take a little glance, okay? Make sure you're checking off the right one. All right, how many more do we need? I'm going to skip that one, okay? But first thing we're going to do is put that 5 over there, put that 3 over there, right? Then divide them, la-di-da. This is different. Do you see why it's different? First of all, there's no plus there. Say it again? I don't know why I'm not hearing you, but they have a different base, thanks. I had to verify you weren't saying what I'm going to do in a sec, because it sounds very similar to what you're saying. That's x, that's 5. So if I do that, I mean, first of all, these are multiplied together, so I don't know what the heck I do. Okay? What can I do with that? How would I solve that if that's all you had? Do you know how to put that in your calculator? You don't? Yes, you do. What's that called? Oh God. It's not called oh God. Change of base. Let's see what happens there. What can I do? I can do something really nice. What would you do here? Ooh, that's y divided by y. What can I do here? Nice. So that's log 81 over log x is 2. And I'm going to do change of base in the opposite direction. How can I write this? Can I write that like this? See, that was the top one, that's the bottom one, right? So that's the top one, that's the bottom one. What squared is 81? Aren't these fun? Okay, now you could put that back and check it on your calculator and make sure that's 2. Not as easily as the other one I did, but okay, you can check it. You can. All right. So that, remember that. You're going to see a couple of those. This one's a little different again, but I think we've done something like this before. We may have simplified it, we just didn't have an equation. What do I want to do here? I want this to happen, right? So You see a relationship between 27 and 3? Yeah. So I want that to do that. Now I just have an equation. It's equal to 1. I want to move this guy first, make it an exponent. So that looks like phi, not 3. Log base 3 of x cubed equals 1. That's gone. So x cubed is 1, which is great, but I want to solve for x. So what must x be? What times what times what is 1? What is the cube root of 1? 1. Okay, that's enough. Sorry, where?
Right there, where you're you cancel the log 3, then you put the 1. You have to do both sides.
That.
Oh, right, yeah.
Yeah, remember this? That's that.